Okay, hello guys. In this video I'm gonna show you how to make a LiDAR scanner for your Unity project, much like the LiDAR mod in Garry's mod or the LiDAR scanner in Scanner Sombre. I've already made a video demonstrating on how it looks, and someone asked me to make a tutorial, so here we go. First of all, you need the HDRP render pipeline and the VFX Graph to do this. And I'm also using the new input system. Just so you know, you can also use the old input system. It doesn't really matter. I've already put a player into the scene. I can look and move around. You can use that player by downloading the GitHub repository in the description, or just use whatever player and camera controller you want. It doesn't really matter. Okay, let's start by making a simple environment for us to scan. Let's make a simple plane and a cube. And honestly, that's it. We don't need any more stuff, I think. This is just for testing purposes, so cube and plane, perfect. Good. Now, for a more important step, we need a new layer. This is the layer for every object that we want to not see but be able to scan. Let's just call this invisible geometry. Invisible geometry, yeah, I typed that correctly, I think. And there we go, we tagged the plane and the cube with our new tag. So we only need to remove this tag out of our culling mask. And we already did, apparently, even though the tag didn't exist. Perfect. Now if we go into game, we don't see anything because these two are tagged as invisible. If we do default, we can see them again, but let's just keep them on invisible. Now, let's create an empty object inside our main camera, so it moves with the camera and rotates with the camera. Let's call this cast point. This is where scanner is going to be scanning at. I'll go back into the scene view and let's just give it a C value of 5, so it has a little bit of distance. Then let's create a new empty object. That's going to be our scanner itself. Let's position the scanner a little bit outside of our player. We don't want our player to be scannable. Let's also give our player the layer tag ignore raycast. Let's do, oh, I did yes children. Yeah, it doesn't matter as long as the collider object has ignore raycast. Perfect. So this error doesn't matter. Next step, we are going to create the VFX graph under Create and Visual Effects Graph. Let's call this tutorial. You can call this whatever you want. Then drag this into the scene to make a prefab out of it, and then drag it into our prefab folder and delete it out of our scene. Perfect. Now let's go to the effect. Open up the effect. I'll make it a little bit bigger so you guys can see it well. First things first, we don't need a constant spawn rate. We need a singular burst. Perfect. And we also don't need to set velocity random and set lifetime random. And our capacity, let's just set it to 1 million. Doesn't really matter. Bounce mode, I set it to manual. And then I set the bounce to be the center at 0, 0, 0. and 100 by 100 by 100. I think that's plenty of size. We're gonna reposition the particle system anyway, so the player should always be inside the bounds. Perfect. We don't need anything in the updates, but we need something in the initialized particle. We need a simple set position, and we need a simple set color. Perfect. Then down here in the output, we can delete the set size overlife and set color overlife, and add a normal set size. And that's it. Perfect. Let's start from the top again. Create a new unsigned integer, and we call that resolution. Drag this in. Let's set this to 100 as default. Then we have to square this, multiply with itself, and then drag it into our count. Perfect. That's perfect. So now the actual fun begins. The way we're gonna tell the VFX graph the positions that we calculate in our script is via a 2D texture, because that's the only way we can communicate with each other. So we need a 2D texture, and that's gonna be the positions texture. That's what we're gonna call it. Positions texture. Make sure you remember what you called these, because we'll need them in the script later. We also need the resolution, and because we don't want to have every particle be at the same position, we need particle ID. So we're gonna calculate that as well. How this works is that we have the texture, and every pixel is gonna represent a different position, so we have to scan all of the pixels from our texture and feed it into the set position. So let's just start by multiplying our resolution with itself again, so it's squared. Then we take the modulo, the remainder of the particle ID, and the squared resolution. Whoops. Like this. Then we need the remainder of that. And the resolution again. Then we need to divide. Perfect. Now we load our texture and we scan it like this. Easy peasy. Now we already have our position. Perfect. But we also want to control the alpha value of our particles. So to get that, we first of all, let's get a color for where is it? Color. See color. We need a particle color, which we will make not black. Let's make it like orangey and alpha and a little bit glowy. Particle color, and we take the alpha value and we multiply it with this, and then we just give the whole thing into the color. Perfect. So now we have the alpha value from the script, but the color of our choosing. Okay, let's move on. particle texture. Let's make this exposed as well. 2D texture, particle texture. You don't have to do this, but it just makes it easier to change it afterwards. Let's use the default particle, and then particle size. Let's use a float for that. Where do we have it? FFF float. Let's call it size. Who cares? And default this to 0.1. Yeah, seems about right. We have this on manual, just checking everything. Seems about right. Let's just add this to additive. Yep. Make sure you compile and save. Whoops. Perfect. So now we are actually done with the VFX graph. Good. Now let's go back into scene view. We go to our scanner game object, add a line renderer. So we have lines that go from our points we created to, like, from our scanner to our points. Make this really thin, and we'll just use the default line for now. You can change this, of course. And most importantly, we're going to create a new C# script. Tutorial scanner. And we're going to add this scanner when it's in the script assemblies. Let's just wait a few seconds. Yeah. Please don't crash. Thank you very much. Put this on our scanner, save it, and open it. Did I? Didn't open it. Okay. Here we go. This is our scanner script. We don't actually need the collections, but we do need generics. Also, let's just do the using statements first. I at least need the Unity Engine input system, the new one. And we're all gonna be using the Unity Engine VFX. And we're also all gonna be using the random keyword, but when we type, whoops, the random keyword, we wanna be using the Unity Engine.random. Whoops, mistyped it. Yep, perfect. All right, we are gonna create a lot of variables. I recommend you just copy those variables from the script in the GitHub, because if I write all of those by hand, the video is gonna be really long. The thing is, we can remove a ton. We can remove those 3 and those 2. So we only need 2 constant strings. That's the positions texture and the resolution. And yeah, actually we're gonna set the resolution to 100 and the points per scan to 40. Perfect. The rest I will like tell you what they do later, I think. Let's just start by programming the actual scanner, because first we have to like scan for points, you know? Okay, in our start method, let's make this private because it looks better. I just get all the information. I get my input actions and I get my line renderer, and I disable it. And whoops, I also set create new VFX to true, because right after that I'm gonna call create new VFX, but the method. Yep. Right after that I'm gonna call apply positions. Yep. They don't exist yet, but let's just put them there anyway. In the update we're gonna do private there, and we're gonna do a fixed update. Whoops, sorry, fixed update. And in here we're gonna call our scan function. Whoops, scan, escape, and then we can do that. Perfect. Before I write my scan function, I'll just quickly copy and paste the change radius function, because that's just simple code. You don't, it's just, if I scroll my scroll reel, I have this math.clamp which changes the radius. You can just copy this. You don't need this, but if you want, just copy and paste it into the fixed update. Let's go with the scan function. Private void scan, because in the scan function we do the raycast. Of course, we do it only if our fire button is pressed. And if our fire button is pressed, we're going to do a for loop till like we don't have any points per scan anymore. That's not a variable you declared earlier. Now we're going to generate a random point. That's pretty easy. Generate random point, and we do, yeah. We actually do it with a random inside units sphere, and then we're gonna do random point plus equal the cast point position. So our random point is inside a unit sphere times the radius, but at our cast point. Perfect. Now let's do the direction. That's pretty easy as well. We want this normalized though. So the direction from the random point, that's don't always trust Copilot. We want it from the scanner, which is transform the position towards the random point. And now we're gonna cast the ray. The way we're gonna cast from, I'll transform the, oops. Of course you need to like tell it to cast the ray first. We're gonna do it from transform the position in our direction. We want a raycast hits to use later. So out raycast hit. The range is gonna be our distance, and we have a layer mask as well. Perfect. Inside here, we're gonna check. We only want to add this point we just gathered to our positions list if positions list dot count is smaller than resolution, times resolution. Only then do we want to go to positions list and add hit dot point. And if we add this point, we also want to enable the line renderer, enabled true, and we have to also set the positions of the line renderer to be correct. Set positions new okay, what's happening here? This is actually correct. Perfect. We want to transform the position towards hit dot not normal point. Yep. Let's just also increase the particle amount by 1 so we can keep track for particles. Perfect. Okay, now what happens if the position list count is already at max resolution? Of course, we need to create a new VFX graph. So we set the bool to true, and then we actually call the create new VFX, and we break out of the loop to not get an error. Perfect. And after the for loop, let's check which one this is. This, we apply positions again. And let's check where the first if ends, right there. Nope, right there. Whenever we stop pressing fire 1, we want the line renderer to disable. Perfect. So now, what happens when we create the new VFX? Let's find out. Create new VFX. We need a return type. We already have 2 usages because we already used it up here. So when we use, when we need a new VFX, first of all, sorry, we only call this if create new VFX is true. So if it's false, just return out of the function. Then we add the current VFX, which we have a variable for, to the VFX list. So VFX list.add current VFX. So we don't delete it, we just add it to the list, and then we make a new one. So now we actually make a new one. I'll just copy this. The current VFX we just instantiated with the prefab. We gave our script at transform the position, that's the scanner's position. Remember when I said 100 by 100 by 100 bounds are sufficient? That's because every new VFX graph is going to be spawned at the current player position, and that's why 100 by 100 by 100 should be sufficient for anybody's needs. The rotation, we don't care about that, and we just put it in a container in the graphs game object to be exact. And then comes something more important. We we will set the resolution unsigned integer to the resolution. We can just cast our integer resolution to unsigned int. This will work, and this is where the name comes into play. So make sure you spelled the name correctly. Okay, next up, we need to create a new texture to pass into our VFX graph. Just create a new 2D texture with width, resolution, and height. Resolution, whoops. And for the texture format, this is important as well. We need RGBA, so we have the alpha channel, and float values. Float because we actually are encoding positions data and not like some color. So don't use integer or whatever, just use float. Float is perfect. And we don't need mipchain, so just set it to false. Then we're gonna make a new positions array, which are the actual positions just inside a colors array. It's just a new color array with the size of resolution times resolution, so that it's perfectly sized for our 2D texture. After this, we can clear our positions list because we're gonna fill it up with new data. Set the particle amount to 0. And make sure we don't immediately create a new one by setting the bool to false. So this can't be called again immediately. This is just for safety. You might not need this, but I don't know, I just did it and it works. So I'll just leave it in. Perfect. So now we've created a new VFX and we have the points, but we never applied data to the texture and we never sent it. So let's do that. Private void ApplyPositions. In ApplyPositions, we change. We need a vector3 array of our positions, which is basically the positions list just passed to an array. Just like this. Then we're also gonna cache some information. I'm just gonna copy this. So we're gonna cache the VFX position, the transform position, the loop length, and the position list length, just for quicker access. We need the VFX position because the VFX graph is not always going to be at world 000, so all of our positions that we send into the VFX graph are gonna be wrong. So we have to calculate the offset first. But before we do that, we make the actual for loop, which goes over loop length. Yeah, okay. So if, let's just check if this works. Yeah, it should actually. Okay. If our index is smaller than the position list length, -1. So if we actually have information that we can encode, then we're gonna encode it. So we need a data object for us to encode in, and that's gonna be of type color. because we're gonna encode into color. And this data object we're gonna fill with a new color object that has, I'll copy this as well. Copy the wrong thing. It has all of our positions. So see how I have to subtract the VFX position, like the VFX graph's position. That's the offset I have to calculate. Don't forget to put the alpha value at 1 so we can actually see this. If we don't have any positions to encode, we still have to create data. That's because if we have too few pixels for our texture, it's not going to work. We can't send a half-baked texture into the GPU. It's gonna throw us an error. And that's why if we don't have any positions, we just fill it up with zeros. No, I'm kidding. We just make it black, and we set the alpha to 0 so we don't see it. So there's a bunch of points there, but you just don't see them yet. Whenever we get the information, we'll override it with the position anyways. So this doesn't really matter. Perfect. So after we made this data, we have to put this data into our positions array, just like that. Good. Now, data is stored in our array. Now, put it into the texture. This is done by just setting the pixels of the texture with this array. Don't forget to call the apply function on the texture as well. Now we need to send this to our VFX graph by just calling the set texture with the string of the property and our texture. And then to actually see this, we have to call reinit. So it reinitializes and uses the texture we just gave it. So perfect. This should work. If it doesn't, that's fine. We're just gonna fix the errors afterwards. Let's just wait a second for it to recompile and everything. Okay, scanner. We need the player input. Just drag in the player itself. The VFX prefab. Call this tutorial. The container, we didn't make one yet. Let's create a new empty object. We call this container, anything you want. This is where VFX Graph prefabs are going to be instantiated into. The cast point, we already have that. Just drag it in here. Let's decrease the points per scan to 40. Like that. I like that number better. The rest can stay the same. Let's check if we have. Okay, we didn't change the default particle. Let's change the default particle to the. Let's just search for particle. Yeah, the actual default particle of Unity. The particle color should be good as well. Size looks fine. Yeah, let's check if the player is ignore raycast. Yep. The scanner, layer mask. We want everything but ignore raycast. This should actually do. Let's test this out. Okay, we have to wait until the VFX graph is compiled as well. And it works. Perfect. We can now scan our surroundings and hopefully not fall off the plane. And there's a cube. Of course, this doesn't really look all that special. You can change the textures, you can change the code to your liking. But I really hope this tutorial was somewhat helpful. Yeah, just if you have any suggestions on how to make it better, please just fork the GitHub project and send me a pull request. I will review it and think about adding it or whatever, because it's really not optimized at all. Anyway, thank you for watching this video, and have a great day. Bye.